Dear guests, my name is Veli Doyar. The title of our study is The Effect of R&D Expenditures on Value Added in OECD Countries. It's a joint study with Dilek Çetin from Kırıkkale University. My presentation consists of 7 sections. After introduction, I will explain the hypothesis. Then related literature will be reviewed. I will give information about the model, methodology, and the data. Finally, I will present the estimation results and conclude. Research and development expenditures and innovation are accepted as the main engine of growth and competitiveness of the nations by most of economists. As stated in Lisbon Agenda, one of the main of the European industry policies is to increase R&D expenditures to GDP ratio to 3%. In 2010, the ratio is 2.9 for United States, 1.91% for EU 27, and 2.4% for OECD countries. In this study, our aim is to analyze the effect of R&D expenditures on manufacturing industry in OECD countries for 1970-2010 period. Our dependent variable is the share of manufacturing value added in total economy, when our concern variable is the share of R&D expenditures in manufacturing industry relative to total economy. Then, our hypothesis is an increase in R&D expenditure share of manufacturing industry positively affects value added share of manufacturing industry. Now I will summarize the related literature. Using panel data for China's provinces from 1997 to 2013, Wang and Wu investigate the relationship between R&D expenditures and economic growth. According to random effects results, coefficients of R&D expenditures from government, from enterprises, and other R&D expenditures are 0.10, 2.01, and 0.22 respectively. Samimi and Alera Soul estimate the effect of R&D expenditures on economic growth in 30 developing countries for 2000-2006 period. Using random effects model, the coefficient of R&D expenditures is found insignificant. Şahin explains the impact of R&D expenditures on GDP in 15 OECD countries. Fixed effect model results show that R&D expenditures have positive effect on GDP with the coefficient of 0.61. Goschin uses panel data including regional GDP and total R&D expenditures by region for 8 regions of Romania over 1995-2010. As a result, a 1% increase in R&D expenditures brings a 4.17% rise in GDP. Using pooled cross-section data from 1965 to 1990 that includes 21 OECD countries, Freire-Serran reveals that if growth of total R&D expenditures increases by 1%, then GDP growth increases by 0.08%. Akçalı and Şişmanoğlu analyzed the relationship between GDP per capita and R&D expenditures per capita for 19 developed and developing countries. Swami's random effect coefficients model results indicate that R&D expenditures have positive effects on GDP with the coefficient 0.71. Sarak uses panel data covering 1983-2004 for 10 developed OECD countries and finds growth rate of the share of R&D expenditures in GDP affects real GDP growth rate positively. Silagi et al. Examined the role of private and public R&D intensities on GDP in Central and Eastern European countries during 1998-2008. Short-run and long-run income elasticities of private R&D intensity are found 0.05 and 0.21 respectively, but public R&D intensity is found statistically insignificant. Finally, Sylvester measures the impacts of industry-financed, government-financed, and total R&D expenditures as percentages of GDP on the average growth rate of output per capita for 20 OECD countries using multivariable regression analysis. But none of the R&D coefficients are found statistically significant. Then the same analysis is implemented for G7 countries. When coefficients of total and industry-financed R&D expenditures are found 0.012 and 0.015, coefficient of government-financed R&D expenditures is found statistically insignificant. All variables used in this study for 34 OECD countries are sourced from OECD's website. Each variable is in terms of manufacturing industry. Our unbalanced panel data consists of value-added share, which is the dependent variable, value-added share of manufacturing industry, employment share of manufacturing industry, investment share, labor productivity index, unit labor cost index, export-import ratio, and R&D expenditure share of manufacturing industry. The production function is utilized to estimate the effect of R&D expenditure share of manufacturing industry on value-added share of manufacturing industry. Value-added share of manufacturing industry is the ratio of manufacturing value added to total value added. Employment share of manufacturing industry is the ratio of employment in manufacturing industry to total employment. Investment share of manufacturing industry is the ratio of gross fixed capital formation in manufacturing industry to total gross fixed capital formation. Labor productivity index is the ratio of manufacturing value-added volume over employment in manufacturing industry to manufacturing value-added in 2000 over employment in manufacturing industry in 2000. Unit labor cost index is the ratio of labor compensation in manufacturing industry over manufacturing value-added volume to labor compensation in manufacturing industry in 2000 over manufacturing value-added volume in 2000. Export-import ratio is the ratio of exports to imports in manufacturing industry. And final, our concern variable is R&D expenditures in manufacturing industry. Is the share of, it is the ratio of R&D expenditures in manufacturing industry to R&D expenditures in total. We use Tobit model since we have percentage dependent variable. The production function is estimated by the dynamic jackknife-Tobit regression because of the heteroscedasticity and autocorrelation problems. The table shows summary statistics of the variables. It's seen the mean of value-added share of manufacturing industry in OECD countries is about 20%, when the mean of R&D expenditure share of manufacturing industry is about 71%. This is the scatter plot of value-added and R&D expenditures share. As seen, observations on Iceland, Slovak Republic, and Ireland fall outside of the main group. Histogram on the left shows the mean of value-added shares of each country. It's seen that Germany, Ireland, and Korea has the highest means of value-added shares. Average shares of these countries range between 27% and 26%. Histogram on the right represents the mean of R&D expenditure shares of each country. Top countries are Germany, Japan, and France. Their average shares range between 93% and 88%. Germany has the highest R&D expenditure share, 93% on the average, but its value-added share is only about 27% on the average, although it is the highest average in OECD countries. This situation could be reflecting the prospective linkages of R&D expenditures. So, R&D expenditures in manufacturing industry also affect other industries. The table shows estimation results. Autocorrelation and heteroscedasticity problems were diagnosed by using Woolrich autocorrelation test and modified Wolf test for group-wise heteroscedasticity. Because of these problems, we estimate dynamic jackknife panel to bit regression by adding one period lag value of dependent variable as an independent variable. Estimations 1, 2, and 3 show Tobit model results. Estimation 4, 5, and 6 show dynamic jackknife Tobit model results. First of all, signs of all variables are found as expected. According to estimation 4, employment share and investment share are significant and at 1% level. When we compare estimation 1 and estimation 4, we can say that adding lagged value of dependent variable to the model reduces the value of the coefficients. In the fifth estimation, the coefficient of labor productivity index is found insignificant, when it is significant in the third estimation, which doesn't include lagged value of dependent variable. The sixth estimation is the final one. As I mentioned before, all variables have expected signs. Again, adding lagged variable reduces the value of coefficients. You can compare estimation 3 and estimation 6. According to the final estimation, a 1% increase in R&D share increases value-added share by 0.017% with 1% significance. The main outcome of this study shows that higher R&D expenditure share increases the share of value added in manufacturing industry. Therefore, it could be concluded that R&D expenditures in the total economy are substantial for value-added growth in manufacturing industry. The results of this study is also compatible with many papers, but the effect of R&D on value-added in manufacturing industry is smaller than we expected. The main contribution of this study is the use of the share of manufacturing industry compared to the total economy values. In this regard, it could be concluded that manufacturing firms in OECD countries could increase their value added in manufacturing by increasing their R&D expenditures. Thank you.
Thank you. Have you got any question?